Hi again. In this video, I'll show you how to do correlation analysis, which is an analysis that you need to do before you do regression. So we have looked at how to do correlation analysis in last week's video. So in this week's video, we're going to look at how to do this correlation. So using the same example that we're going to look at, which is the relationship between providing digital training as your program intervention and looking at whether this digital training has any influence on the outcome, and this outcome is the digital skills of the elderly. So whether we provide more digital training, whether this will improve the digital skills score of the elderly. To do that again, we're going to analyze, go to correlate, go to bivariate, which is your digital training and as a dependent variable, and your digital skills. In a correlation, it doesn't ask you to put which one is dependent, which one is independent variable. It just put the variables in, right? So just put the variables in. It can be 2, it can be 3, it can be all of them, depending on what you want to see. And I don't want to click anything else. That's fine with me. I just go to simply very simple and quick correlations. Just have a look. So what can you say there? So just look at, if you look at a ruler again, you take the diagonal, you can see the 1 and 1. So you can read it, the one above or the one below that diagonal 1 and 1. Yeah? So I'm going to look at the one at the bottom. So you can see the exam score, which is your dependent variable, has relationship with your independent variable, which is the digital training, right? And the relationship is 0.714 with 2 star. The 2 star, look at the bottom, it shows this correlation is significant at 0.01 or 0.01, which is highly significant. Right? Remember, we want the significance of p-value. This is the same as p-value. We want this significance level to be lower than 0.05. Actually, the lower the better. We have this 0.7. And you know, in correlation, it's only range from 0 to 1. If it's a score of 1, it means it has a perfect correlation, which means that 1 unit of increase of independent variable will be followed by 1 unit increase of independent variable. So it looks like that. So here is 0.7, which is quite strong correlation between your digital training as your independent variable, or in the language of your in the language of your logic model, digital training is your independent variable, and it has a strong relationship, strong and significant. We have a positive and significant relationship with the independent variable, which is the digital skills. And the coefficient correlation R is 0.714, and it's significant. That's it. And now we have done 2 analyses. In the first video, in the earlier version of this video, I'll show you how to do scatter plot. We have done the scatter plot. We have seen the evidence, and then we have done this correlation. And correlation also says there is a strong relationship between these 2 variables. So this is the end of this video on correlations. Thank you. Bye.